writing it down as we go, Corey?
Do we have to write two separate pictures for that?
No, that's a great question. One would be fine. Great question. All right, we're going to do 17. So we've got our diagram already, Jamari. You're good with that? Okay, then I'm going to label some more parts. It says that PQS equals 3x. So angle PQS, the measure of angle PQS, angle PQS. So that's in here. That's 3x, right? And it tells me the measure of angle SQR is 5x minus 20. 5x minus 20. Oh, and it tells me this word, so I'm looking at this, Jamari, and I'm thinking, well, how can I write an equation? Because I don't know what the big angle equals, right? But I have to look back up and like, oh, it says it bisects, so that gives me some information. That tells me that this angle and this angle, how do those two angles compare? If we bisected a big angle and made two angles, what do we know about those two angles?
They're the same.
But say it again, Jamari.
I don't know.
What's the word we use if they're the same? Congruent, right? So we know that they're congruent because bisector of two equal sections, right? So it puts it into two equal sections. So now we have enough information to write an equation. So we're going to write, I'm going to mark these. And that's the other thing we should have done when we drew our picture. We should have indicated that they were congruent, okay? Okay, so now we're going to say that PQS 3x equals the measure of SQR, which is 5x minus 20. And now we're going to solve for x. Going to get our variables on the same side. Subtract 3x from both sides. 3x minus 3x is 0. For some reason that throws kids off when you have nothing left over there, but it's 0. 5x minus 3x is 2x minus 20. I ran out of room, so I'm going to move up here. I'm going to add 20 to both sides. So 20 equals 2x. I'm going to divide both sides by 2. And now I know that x equals 10. So that is the first part that they asked me to do. And then it says to find the measure of PQR. So in this problem, PQR was the big one, right? So really all I have to do is I have to find the measure of one of these angles because we know they're congruent. Does that make sense, Jamari? So the easy one would be PQS. So PQS is 3x, so we're going to replace 10, the x is 10. So now we know that this angle and this angle both have a measure of 30. If that's the case, now we know our big angle is just 2 times 30. And that's where the 60 comes from. Make sense? Okay. So for me, especially if I sit down and I haven't been working in geometry for a while, I look, I get stumped, I get puzzled, I go back and look again and see what I missed the first time. You already pick your head up. All the way up. Any other questions on the homework for last night? Jamari?
25.
5. Is that what you asked? Or somebody else? Okay. Nobody went up. Who's laughing?
You can do 20 first. He wants to do
20? Okay. So the measure, so this is from the same diagram. It says the measure of PQS, so PQS is equal to 210, and the measure of SQR is 5x minus 17. I'm going to set it up first, so I'm not going to work it out all the way, okay? So this is very similar to this one. So we're going to do the same thing. We know that PQS and SQR are congruent. So we know they're going to be equal to one another. So it's 2x plus 10 equals 5x minus 17, and then we're going to solve for x there and do the same thing, okay? And then once we know that x is 9, to find the measure of angle PQR, we just multiply, what is this one, PQS is 2x plus 10. We would substitute the 9 here, 2 times 9 plus 10. Oh, that's the wrong one, not me. No, that's right, that's 28. But that's only one of the angles. Since the angles are congruent, we would take that 28 and we multiply by 2 to get our 56. Make sense? The 2 times 9, so PQS is one of the angles, right?
What if you multiply it by the other?
You can't multiply it by the other one. Because 28 times 28 is going to be a big number, right? 28 times 28 is not the same as 28 times 2 or 28 plus 28.
So I do that.
So this one, in this group, I could have done this one. You want to do this one? We can do this one.
I was asking.
I just did this first. It doesn't really matter. Yep. So here, like you're going to get the same thing. 2 times 9 is 18 plus 10 is 28. Here, 45 minus 17 is also 28. Does that make sense? Yes or no? I can elaborate more if it doesn't. My handwriting's kind of bad. 5 times 9 minus 17 equals 28. Okay. And now, if this is 28, then this one is 28 as well, right? So add this together and multiply by 2. That's how we get to 56. You said 20, right, Jamari? 5, you just get 20. Okay. It tells us here that MLN and JLK are complementary. Do you remember what complementary means, Jamari? You got your notes from yesterday? Anybody help him? What does complementary mean? Pardon? Did you say? I couldn't hear. What's complementary mean? You what? In my notes? Two angles that have a sum of a right angle. What is the measure of a right angle? Right. So if it says that these two angles are complementary, then we have to know that means that if you add them up, they're going to equal 90. Okay? So that's what we're doing here. And you do have to learn that terminology. You should be working with all your notes out at this point. Like today, when we do today's homework, you probably need all of your notes from this section out, especially the notes from yesterday and today. There's a lot of new terminology. So if we know that these two angles are complementary, and we know that angle MLN is 7x minus 1, I'm going to write it up here because I like that visual. And the measure of JLK is 4x plus 3. The first thing they asked me to do is to solve for x. Well, complementary means they equal 90 degrees, right? So I'm literally just going to add those together. So 7x minus 1 plus 4x plus 3 equals 90. We're going to combine like terms, so we're going to 11x plus 2 equals 90, right? 7x plus 4x, yep, negative 1 plus 3, yep. Now we're solving our equation. We're going to subtract 2 from both sides. So 11x equals 88. Divide both sides by 11, and x equals 8. So now it asks us to find the measure of both of those angles. So now we take that 8 and we plug into the expression for each. So MLN was 7 times x, so now we know that x is 8. So 56 minus 1 is 55. We know that JKL was 4 times x plus 3, so now it's 4 times 8 plus 3. So it's 35. When they asked us to check it, we had to know that if we add these two together, they equal 90. So 55 plus 35 does equal 90. Okay? Anybody else? All right, we're going to move on. We do have a full, Pedro?
Can you go back to the interest rate
7 and 8. Yeah. Make sure everyone's got something to write with. We do have to get move on. Leo? 8? Okay. I'm going to show you history of child still. Because we do have a full thing in there to go through. All right. It says here's a diagram. It tells us if we're looking at number 8 as a measure of COD. The COD, that's this big one, is 8x plus 13. Does that make sense? Then it tells us the measure of VOC, that's this little one, is 3x minus 10. Then it tells us the measure of VOD, so that's even bigger. That's this whole thing right here, Leo. Does that make sense? And they tell us that's 12x minus 6. So much like the segment addition postulate, this angle addition postulate says if there's this big angle, it's split up by array. Now we have two parts of that big angle. This part plus this part equals that part. Okay? So it's 8x plus 13 plus 3x minus 10 equals 12x minus 6. Okay? You're combining your last term. And I'm not going to solve that whole equation. But when you solve this equation, you do get x equals 9. Okay? Once you know that the x is 9, now we can take that 9 and plug in to find the measure of the other angle measures. Right? And that would be the other angle measures that they've mentioned here. So there should be 3 answers. So 8 times 9 is 72, plus 13 is 85, right? We'll replace the x with our 9. Here, 3 times 9 is 27 minus 10, so it's 17. That big altogether, 12 times 9 is 108, minus 6 is 102. If we add these together, it should equal that as well. Okay? All right. We are going to go ahead and start on this. Nope, but I think I've got a sharpener I can get you. I can't talk over a pencil sharpener. Okay? So, everyone's favorite properties of numbers. You learned about them in 7th grade, they're 7th grade benchmarks. You learned about them in 8th grade, they're 8th grade benchmarks. You learned about them in algebra, they're benchmark in algebra. Carla, face forward. Your whole body, buddy. Your whole body. Knees under your desk. You're welcome. All right, so we are going to review. This is not new. You should have seen it at least 3 times at this point. All right, addition property says if we have 2 expressions that are equal to one another. Ja'Cory, we're starting, bud. You ready? Get your notes on top. Everybody get your notes on top. If we have 2 expressions, A and B, they're equal expressions. If we add the same value to both of them, those expressions are still equal. They don't have the same value necessarily. If you want to see a numerical version of that, what we're saying is, if 3 equals 2 plus 1, and we all know it does, then 5 plus 3 is going to be equal to 5 plus 2 plus 1. So if we add the same number to those equal expressions, then the left side would be equal to the right side still. So we have not changed the equality of that statement. The expressions are still equal. Same thing with subtraction. We've got 2 expressions, and we subtract the same number from both of them. The same value from both of them, then they're still going to be equal expressions. So everything that's up here should be on your paper. So you're all writing the black and the red. If 3 equals 2 plus 1, then 5 minus 3 equals 5 minus 2 plus 1, because those are equal expressions. Forgot an N there. Same thing with multiplication. We've got two equal expressions, and we multiply by the same value. Those expressions will still be equal. So the whole premise of solving equations, we can do whatever we want to an equation to solve it as long as we do the same thing to both sides. So if 3 equals 2 plus 1, and we multiply both of them by 3, they're still equal. Same thing if we divide. Just one thing different about dividing. You can get away with it once, but twice is not okay. So the division is different than all the others because you can't divide by 0. Everybody should have a calculator for that. Once you finish writing, plug in 10 divided by 0 on your calculator. And then plug in 0 divided by 10 and see how they're different. So on your calculator, 10 divided by 0. It says error because it's an undefined answer. Remember in algebra, you spoke of a vertical line with undefined. Can't divide by 0. But 0 divided by 10 is 0, right? You're going to get an error on here. It's undefined. We don't divide by 0. All right? So the same premise, though. You can divide by anything except for 0, and you don't change that equality. Those expressions are still equal. Not equal to what they started with, but the left one's equal to the right one. All right, go ahead and write the numerical table for division because I'm ready to change my page. Dominic, you caught up with me, buddy? You all good?
I'm not done.
Wait. Okay, sweet. So we're going to, while they're finishing up, we're going to be using these properties to say why it's okay to go from one semi equation to another semi equation. Why it's okay to go from sigma 1 to sigma 2, or sigma 2 to sigma 3, and these things that we call proofs. Used to be back in the old days, almost all of our chapters are filled with proofs. You guys don't have very many proofs. If you ask your parents about proofs in geometry, I would say 9 out of 10 of them, because they hated the proof part of geometry. I happen to really like them. Probably my favorite math. So we did a lot of proofs. We'll come back to that one if you need it. Later at the end, we'll come back. These should all be reviewed. You've done these before. The reflexive property just says a number is always equal to itself. So 5 is always equal to 5. The value 5 is always the same, is always value 5. It's a captain obvious statement. Seems like it doesn't need to be said, but that's the reflexive property. Symmetric property basically says it doesn't matter which side of the equal sign it's on. It's still if A equals B, then B equals A.
It's just switched up?
It's just switched up. The location around that equal sign does not affect the equality. So 5 equals 3 plus, if 5 equals 3 plus 2, then 3 plus 2 equals 5. Transitive property. The transitive property says if one expression, let's say expression 1 is equal to expression 2, expression 2 is equal to expression 3, then expression 1 must be equal to expression 3. I think it makes more sense when you put actual numbers in it. So for example, if we say that 5 is equal to 3.2, transitive property is the longest one, then if this one is equal to this one, and this one is equal to this one, then the first one has to be equal to the third one. Okay? The first is equal to the second is equal to the third, then the first has to be equal to the third. Last but not least, probably one of the ones that's used the most is the substitution property. It says if expression A is equal to expression B, then B can replace A in any expression. And so getting back to our 5 and 3 plus 2, what that means is, if 5 equals 3 plus 2, then we can replace 5 in any expression with 3 plus 2, and vice versa. We could replace 3 plus 2 with 5 in any expression, which is what we're much more likely to do. So remember, the substitution property, you have to replace it with an equal value. Just like in sports, if you substitute a player, quarterback for a quarterback, a pitcher for a pitcher, kicker for a kicker, a catcher for a catcher. I'm stuck on football and baseball. There's sports that pop into head. A center for a center in basketball, forward for a forward in basketball, right? So as long as it's the same value, they're interchangeable. You can use whichever one you prefer to use. Not yet? Sorry? Is it on Canvas? What do you mean? It's what on Canvas? It will be. I'm recording it right now. It is.
So we're all being recorded.
Okay. I'm going to go on if you need. I'll come back at the end. So just make a little circle or mark on it, a star, and I'll come back at the end. Okay. So we're getting closer to proof. This is not a proof. But what we're doing is we're going to give, how do we know that we can go from this statement to this statement? And that's what we're doing when we write proofs. We're giving a justification or a reason. If you're trying to justify your actions, you're trying to tell me why your actions are okay, right? You're justifying your reasons for going from one statement to the next. You're telling me how do you know it's mathematically correct. This first one happens to have two. It is the trans one, right? The transitive one. And transitive is the best choice for this. But substitution would also work. So if you go from here to here, you substituted 8 with 4 plus 4. We know that 8 equals 4 plus 4, so that would work. But you can also say the first expression equals the second expression equals the third expression, which means the first has to equal the third. Typically, if substitution in another property will work, we'll let you use the other property. So that's how it'll be on the test. Substitution is pretty versatile, but if we can use another property, I'm asking you to use another property for our purposes. Otherwise, people kind of default to substitution, and their understanding is not quite as deep. So we're going to go to example 2. Which property do you think this one would be?
Symmetrical.
Symmetrical. That order around the equal sign doesn't matter. 5 is on the left, it's equal to 1 plus 4 on the right. 1 plus 4 on the left is equal to 5 on the right. That does not affect the equality of the statement. Symmetric, not technically symmetrical, we would call it symmetric, okay? Okay. Yes, you would get it wrong, or I'd take off some points. Yes, not symmetrical, it's symmetric. All right, example 3. What do we do when we, from x equals 3, they shove their player in, substitution, that's exactly right. Somebody wanted to use multiplication here, and I understand what they're thinking, but really, we're going from this statement to this statement, we substituted the 3 in for the 5. I haven't actually multiplied it yet, right? If we had something below that, we would go with multiplication. And then the next ones have equations in them, and be careful, because while this looks like it might be a subtraction property, what we want to do is give the property that tells us it's okay to go from this step to this step. So think, what steps would I do to solve this equation? Because this is the solution to this equation, right? 10 minus 3 does equal 7. So how do we go from here to here? What property says it's okay? Or think about it this way, what do you have to do to solve that equation from here? Add, yeah, what are we adding?
7 plus 1.
What are we adding?
7 plus 3.
Not adding 7 and 3. We're adding 3 to both sides, right? But it is the addition property. So 6 times x equals 18. How do we go from that step to x equals 3? What property did we do to go from 6 times x equals 18 to x equals 3? How? Division. Very good. Okay. Y'all caught up with me? Okay. So now we're getting to the last property which we talked about earlier. Distributive property, remember that's the type of multiplication where you take a factor on the outside of a set of parentheses and distribute it to everything on the inside. So A times B plus C equals AB plus AC. You're writing what's on the board. We are going to finish, so we are going to be speeding up here. And the distributive property works when you're multiplying with addition in the parentheses or subtraction in the parentheses. So all of these properties can be used as reasons or justifications for steps in our proof. On the one, we learned about segments, the segment addition postulate. That one could be used. We could also do the angle addition postulate. So all of these things we've learned is justifications for steps we can use in our proof. Proof is a strong argument for something. In this case, it's going to be an argument that proves how you get from one step to the other. So a proof, a convincing argument that uses deductive reasoning. In other words, it has to be an argument based on things that we know are true. Okay? The particular kind of proof that we're going to work with is a 2-column proof. It just means it has 2 columns. And the proof on your notes is an example of that. So this is a 2-column proof. 1 column, 2 columns. I'm sorry, I need to go back up, don't I? Yeah. Sorry. There we go. So statements, those are the things you're looking at from the top to the next statement. What do we do to get there? Right? What is the justification? What is the reason it's okay for us to go from this step to this step? And the reasons are our justification. That's where we're going to put our properties. Very often, one of our reasons is going to be given. If they write literally the given statement, so given in math means they're telling us it's true. In this case, they're telling us that 2 times x plus 3 equals 9, and they want us to prove that x equals 3. So this is a given statement. This is what we're proving. Whatever you're proving should be the bottom statement. That should be the last thing in your proof. So 2 times x plus 3 equals 9, that's a given. So the statement, the reason is given. What do we do to get from statement 1 to statement 2, Sharad? How do we go from statement 1 to statement 2? This is 2x plus 3 equals 9, now 2x equals 6.
Subtraction?
Yes. What do we subtract?
9?
No.
Or the 3.
The 3, right. This is subtraction property of equality. Here, 2 times x equals 6. If you divide both sides by 2, so it's proven using those properties that the solution to this equation is x equals 3. All right, this statement is the same as the given statement. So what is the reason that we're going to write there? Literally, it's given. Some of y'all are going to miss it on the test. I'm so sorry right now. I'm telling you. I'm always surprised. How do we go from parentheses to no parentheses? Distributive property. How do we go from step 2 to step 3? Subtraction. How do we go from step 3 to step 4? Yep, 4 times x, we're dividing both by 4. Any questions? So far we've done some basic ones, haven't used really any of our new geometry things, but this one we're going to use some geometry. So when you get here, make sure you're paying attention to the given information, the diagram. What does this 2 times x plus 3 mean here? What does this 3 times x mean here? The given is xy equals 20. What does that mean? Xy equals 21 rather. What does that mean? Not division. We're not talking about, I'm asking you, what does this statement mean? Xy equals 21.
Angle. Right.
So you're thinking that x times y, right? But remember, look over to the right. We have a diagram, right?
X to Y.
So x to y, or the length of x, segment xy, right? So the length of xy is 21. So it doesn't hurt to mark these things up either to kind of get yourself organized, right? X to y, the length of that. So it makes more sense now that this 2 times x plus 3 refers to the length of xz. Makes sense that the length of zy, they're representing as 3x. So this is given, we're proving that x equals 3. And this particular proof, we're not going to write the words given because and there's nowhere where we see this statement. If they wrote this statement, and they could, our reason would be given, but they don't. All right, so at first when I looked at this in second period, the first time I taught it, hadn't looked at it since last year, I was thinking the same thing for instance. X times z plus z times y equals x times y. Which remember, normally when we're using variables and equations, they're lowercase, number 1. And number 2, they give us a diagram of a segment, right? So I made the same, because that's the first thing that popped up. I won't even say a mistake. That's your first default when we're talking about math, because you're used to doing algebra. So this says the length of segment xz plus the length of zy equals the length of xy. So what did we learn that tells us that's so? You guys remember what we called that? No. We're adding 2 what? Adding 2 segments, right? 2 parts to get the whole. See, I know that's right. So that is a segment addition property or postulate. We learned it as a postulate, but same thing. So now, what did we do to get from 1 to 2? So this is a real geometry proof. It's not a real hard geometry proof, but this is a more typical looking proof. How did we go from 1 to 2? No, that's from 2 to 3. I'll give you that. We'll uncover that one. From 2 to 3, it's distributive. So this refers to the length of xz, right? Well, here they give us the length of xz as 2 times x plus 3. So we replace the xz, what's it called if you replace something? We substituted this indication of the length of xz with this algebraic expression. We substituted the measure of zy, or the length of zy, with 3x, and then we replaced it with what we knew was the length of xy. So that is a substitution property reason for justification. What did we do to get from 3 to 4?
Division.
Don't guess. Look at it. Don't guess. Look at it. I heard somebody say it right. You combined it. When you combine things, is that add, subtract, multiply, or divide? Add, right. So 2x plus 3x is 5x, right? So that is the addition property of equality. And now this is ones we've seen before. So to get here, we had to subtract 6 from both sides. To get here, we divided both sides by 5. Let me know if I need to go back to someone after you guys finish this. Correct?
The, two columns.
The 2-column proof. Okay, is everybody finished this one? If you're finished, scan and submit on your phone and get your phone put away. We're not texting or anything on it. Tiana? Okay, I'm stopping right here for straws and I'll go back for you.
Okay.
All right, anybody else need something? Yuri? I can't hear you. You can, just come stay with your scan in a minute and then go back to your seat. Lennon? Mission property? Okay. Okay. I'm going back to, which one did you need, Tiana?
Multiplication and division.
Okay, is that the one one of these you needed to, Corey? Did you need some of those, multiplication and division? Substitution? Okay, I'll go back to that one. Going back to substitution in a minute. Kyle, I'm working on our worksheet now. Once you scan and submit it, we've got 6 or 7 minutes. We're working. We're not packing up. We're not chatting. We're not getting on our phone. Our phone should be back in our backpack. Yes, please do. Tiana, are you almost done?
I'm getting multiplication and
I'm going to stand and watch for you. Corey, you can go ahead and start a couple of problems. Hey, look at number 1. Number 1 is kind of a trick question. You caught me? Look at number 1. I'm going to tell you it's a trick question because I don't want it to be a trick question. It's the first time you've done it. So look at number 1. From going, the justification or the reason for step C. Look at that. So when we solve an equation, we're almost never going to do this because we get to use a calculator. They went from 2.25x to 225x. They multiplied both sides by 100, which is okay to do. I would not have done it. It was very counterintuitive for me, so I'm telling you that is a little bit of a trick. Yes, you have to show work. Yes. On the proof you're saying? No, not necessarily on the proof. But some of the problems will require work. Are you good, Tiana, on that one? Okay, I forget, Corey, you said, all right, which one do you need to say, Joe? Okay. You go from B to C, what do you go from 2.25 to 2.25? Yeah, you multiply by 100. Yeah. Well, what did you do good so you can get given those 2.25x, 2.25x? They multiply. So this reason is multiplication.
So they go on C. So with D goes to that?
See what I just told you, see what multiplication?
No, B on it. I'm at B.
B. I didn't look at B. B, yes. B would be subtraction. Victoria, you good? Need another one? You need what, buddy?